One more way of looking at this same simplifying of a radical expression where there's a fourth root in the denominator. Sometimes, and again, this is kind of up to you with what you prefer, sometimes it might be easier to look at them in terms of rational exponents. So here's how I might simplify the exact same expression using rational exponents instead of the roots. So in order to simplify or rationalize the denominator, I need to multiply the top and the bottom by the same thing. In this case, I need to have a rational number in the denominator. Well, I want to have 3 to the first power. That's what I had here when I was all done, was 3 to the first power. So I need to multiply by 3 to the 1/4 plus whatever is going to be here needs to add up to 1. So I'm going to multiply that times 3 to the 3/4. And I'll multiply the top by the same thing, 3 to the 3/4 power. In my denominator, I have 3 to the 1/4 plus 3/4 is 4/4 or 1. So I'm going to have 3 to the first, which is nice. Numerator is a little bit goofy here. Here's how I might think about this. I might simplify this expression and write it in terms of 2's and 3's. This is -3. Think about it as being raised to the first power or the 4/4 power. I'll show you why in a second. Plus 6 I could split up into 2 and 3. That'd be 2 times 3 raised to the 1/4 power. And if I have 2 times 3 to 1/4, the 1/4 applies to both the 2 and the 3. You'll see why we might do this in a second. So I'm going to take these two expressions and this one and multiply them together over here. So the -3 to the 4/4 times 3 to the 3/4, those have the same base. They both have a base of 3, so I can add their exponents together. 4/4 and 3/4 makes 7/4. Now it's negative because that one was negative. So -3 to the 7/4 power is going to be the first of these. That's this times that. Now before I take the 3 and just multiply it times this expression, I'm going to take the 1/4 and apply it to both of these. So I have 2 to the 1/4 power and times 3 to the 1/4 power. And I'm going to multiply that expression times this, 3 to the 3/4. Now since it's multiplication, multiply, there's no distribution here. Okay, so 3 to the 3/4 is going to multiply times 3 to the 1/4. Add these exponents together, 1/4 and 3/4 makes 1. So I got 3 to the first. Now I'm adding these expressions, so I put plus 3 to the first, I don't have to put that, times 2 to the 1/4 power. Now you're looking at this expression here and saying, well, how in the world does it turn into this over here? Well, I'm dividing both of these terms by 3. When I take -3 to the 7/4 divided by 3, I would subtract exponents because it's the quotient of powers property. Imagine this is 3 to the first or 3 to the 4/4. Well, 7/4 minus 4/4 is 3/4. So I have -3 to the 3/4 power. And this is canceled. Then this will also cancel because 3 divided by 3 is 1. So I have plus 1 times 2 to the 1/4 power. And that would be a nice acceptable answer because there's nothing in the denominator and I have only positive exponents. Well, how does this match up? Well, 2 to the 1/4 is the same as the 4th root of 2. I think you get that one. -3 to the 3/4 would be the same as taking the opposite of the 4 on the bottom means I'm taking the 4th root of 3 cubed. Now you can put the cube on the outside of parentheses or inside the radical. It doesn't really matter. So 3 cubed in here, well 3 cubed is the same as 27. So I got the opposite of the 4th root of 27 plus the 4th root of 2, just like I did when I left it as radicals. So either way is acceptable. Whichever is most convenient for you, choose that way. But pick one, stick with it, do your best. Have a little bit of imagination when it comes to this. And again, sometimes the answer might be close enough. So just give it your best shot.